Hey guys, how you doing? And welcome to another tutorial on A levels. Hope you guys are doing great. Great to see some of you guys coming back. Stuart, thank you very much for being on the chat. That's the guy from who created ExamSolutions, who's going to be helping you guys today. It's good to see so many of you guys coming back. Marcus, Din, Erica, Ella, Natalie. It's great to have you guys on. Today we're going to be looking at integration today. We're going to be particularly looking at integration via substitution, one of the several methods of integration that you're going to need for year 2 A levels. Okay, so hopefully we can try and get you guys involved as much as possible. As I said, we've got Shu on the chat. Ask as many questions as you can. We'll try and get you guys how to recognize the type of to recognize that, when you see an integration by substitution question, how to deal with it, what substitution to use, etc. Okay, so without further ado, let's just get straight into it. Let's go. All right. Okay, so before we actually start, I'd like to just do a short exercise, okay, just to get your brains warmed up. Let's have a go. It's A2, by the way. All right, let's go. First question, find the integral of x to the power of 4 with respect to x. X to the power of 4 dx. Find the integral. As quick as you can, let's go. Just a couple of questions to get us warmed up. Yeah, this is an AS question actually. So yes, okay, so we've got Ella straight in with x to the 5 over 5. Is she correct? Oh, we've got Din, we've got Eric or x to the 5 over 5. See, some of us making a few mistakes. All right. Okay. Yes. We're not going to forget our constant of integration. The answer using the formula where we raise 1 to the power and divide by the new power. So we add 1 to the power and divide by the new power plus the constant of integration. We get x to the power of 5 over 5 plus the constant of integration. Okay. All right. So well done to, I think it was Din there who got the answer. Oh, actually, wait, he forgot his over 5 there, but I think it's probably a typo. Next question. This is the last warm-up question. Let's go. So it's Ella first in. Well done, Ella. Good stuff. Is this a class thing or always different people? Well, it's a class thing. It's for you. It's for everyone. Okay, and it's free. Yeah. Okay, so we've got Ella coming in with u times by x to the power of 3 over 3 plus c. Anybody else? So I've asked you to find the integral of u times by x squared du, okay? So we've got Din coming in with 4 over 3 x cubed plus c, I believe. Is that right? Anyone else? So Ella's didn't see the du there, okay? So hopefully we're, starting to see that, it's very, very easy to be caught out in these integration questions, okay? Anyone else with an answer? Okay, so I'm going to go through the answer. And the answer is the integral of this function here is equal to x squared times by u squared over 2 plus the constant of integration. Now you might be wondering what happened here. Now you've got to pay attention to this guy, okay, du. All it means is integrate this integrand with respect to du, okay, with respect to u. Okay, that means it looks at all other terms as constant. All other terms apart from our u terms as constant. Okay, so you've got to almost imagine the x squared term was constant. Okay, how would you treat it? Right, you would just simply integrate u by adding 1 to the power, which would give you 2, dividing through by 2, and that would give us the answer. Okay, So make sure that you guys don't get tripped up on that. It is a potential question, potential exam question. All right, so let's now look at integration by substitution. All right, now the whole idea or the method behind it is, well, to first of all recognize that the integrand that you are trying to evaluate is it's not standard. Okay, it's not something that you can easily just add the power and divide by. Okay, so what you have to do generally is find a way to make it something that's easier. Okay, so find a way to effectively change the variable and then which would give you an integrand which is a lot easier to integrate. Okay, so the goal really is to try and get x's are x's and dx's, which we have here, into u's and du's. Okay, so the first way we go about this, and this is the general method I use in pretty much sequential order. Okay, the first thing is you need to assign u to a function in the integrand. Okay, and we'll talk about what, how to do it and what to look out for and things like that. Now I've assigned it to u equals x plus 1. Okay, we then need to differentiate this function with respect to x, giving us du over dx is equal to 1. Now I I like to rearrange to make dx the subject. Okay, I know some of you might be aware of another formula which you'd use to um, substitute equation integrands, but the next stage generally, well, I like to use it, is to let dx be the subject. Okay, and then we substitute our u terms back into the original integrand. Okay, so as we assign u to be equal to x plus 1, we put this is equal to u to the power of 4 times by du, which is equal to dx. So we simply just substitute, and now you can see that we've now achieved an integrand that's a lot easier to integrate. Okay, so integrating u to the power of 4 with respect to u, we get u to the power of 5 divided by 5 plus c. Okay, last but not least, you need to remember to not forget your to replace your terms. Okay, so all you do is, using the assigned value of u, we substitute the x plus 1 back in, and giving us a final answer of x plus 1 all to the power of 5 divided by 5 plus our constant of integration. So this is our general, this is a general way we like to do integration by substitution questions. Okay, let's move on. Okay, now in general, we've seen a lot of students ask, well, what do I choose to be the substitution? Which function do I assign to u? Okay, now we're going to do a little exercise. I'm just interested to see what you would allow u to be equal to. Okay, so here's the first one. Which function would you assign to u? What would be your substitution? Tell me. So we've got Ella coming in with x squared plus 3. Anyone else? Erica, x squared plus 3 as well. Anyone else? Anybody else? X squared plus 3. Looks like we've all got the same answer. And I would agree that I would allow u to be equal to x squared plus 3. Now, when I look at this, okay, of course, we know it's a substitution question, right? But what we should really see is that we have the product of two different functions. And whenever you have the product of two different functions in an integration question, try and look at whether one of the functions, and in this case, this is an inner function, can differentiate to give you something that's already there. Okay. Now, as you saw previously, differentiation actually plays quite a large factor in integration, okay, by substitution. It's part of it. So we're going to see exactly how it works, okay? All right, so assuming we let u be equal to x squared, what we would then do was we'd take the derivative of u with respect to x, which would give us 2x. Rearranging the equation, we get dx is equal to du over 2x, okay? So now substituting our values, our u terms back into the original integrand, we get the following. And as you can see, the 2x's now cancel, okay? So you should hopefully now be able to see the significance of using what could be easily differentiated to get something out into, sorry, something inside the function. And you can see that that 2x actually comes in the denominator, right? So that's where we get the cancelling effectively, okay? And it will give us an integrand of u to the power of 3 with respect to u, okay? Which is a lot easier to integrate. Let's see the next one. Which one would you assign, guys? Good stuff, Ella. I think Ella was in there first. Well done, Erica, as well. Jaden. Which function would you assign to u in this case? So Ella comes in with x plus 2. Anybody else? All right, Erica comes straight in as well, x plus 2. Anyone else? X plus 2. So we've got the 3. Does anyone else have any suggestions? Anyone else? Okay, I can confirm that, yes, I would have assigned u to be equal to x plus 2. Now, in this case, we have a quotient of functions, right? And you can't split this up into a sum of fractions because we've got this square root sign and we've also got a sum underneath, okay? But you'll see what happens when, we go forward with letting u be equal to x plus 2. Okay, so taking the derivative of u with respect to x, we get du over dx is equal to 1. Rearranging to make dx the subject, we get the dx is equal to du. If we substitute our u terms back into the original integrand, we get u is equal to x plus 2 and du is equal to dx, leaving us with this term we need to eliminate somehow. So we have to think, how do we find x in terms of u? Now, that's why I've labeled this equation 1. If we simply just let x be the subject, we've now got x in terms of u, right? It's equal to u minus 2. All right, substituting that back in. So what can you observe here? What we can really observe is that we now have, from having a single term divided by the square root of a sum of terms, we now have the difference of terms divided by just one term, which we can split up into a difference, okay? And we can then evaluate, okay? So that was good, guys. Very, very well done. Let's move on. Let's see which function you would assign to u here. Think about it. Think about what we've said before. Who knows? So Erica says e to the power of x. Okay. Anyone else? Same as Jaden. Anyone else? Ella, same again. All right. Anybody else? So we've got the same 3. Does anyone else have any other ideas? Hey, Anne, how you doing? Welcome. If you just joined us, we're currently figuring out how to assign a function to you. There's no hard and fast rule, but there are a couple of things you should be thinking about based on the process of integration by substitution, which largely involves differentiation. Okay, all right. So I will tell you that the function I've actually assigned to you is x squared. All right. Well done, Kevin. Now I haven't actually tested the other guys, Erica's and Ella's. I'm not sure if it works. If maybe Stuart can help me out on that one. Now, as I said before, you're always looking for part of the function. So we have a product of two functions, x times by e to the power of x squared. Now you're always looking for a function which, when you differentiate it, it gets you something that's like what's already in the function. Okay. Now, when we differentiate u is equal to x squared, we get du over dx is equal to 2x, okay? Now, it's not equal to x, but it's like it. And as you'll see, as some of you may know, constant terms can be brought out of the integral. Okay, so we're really interested in eliminating just the x terms and changing the variable to u terms. Okay, so rearranging this to make dx the subject, we get dx is equal to du over 2x. Substituting our u terms back in, this is what we get, and now you can hopefully see the cancelling. Okay, and this will give us a final integrand of e to the power of u times by du over 2, okay, which we can easily integrate, as the integral of e to the power of u is just e to the power of u. Okay, so I think it was Kevin on that one first. Really well done. You got to think about these things, but you know, just try it. Just try it, and if it doesn't work, maybe try something else. All right, so now we're just going to go to the next level. I'd like to see now, based on what you assign, I'd like to see if you guys can find the change of variable, okay? So what integrand do I end up with after I've changed the variable here? Okay, so I'll give you a clue, and we're going to be assigning u equal to sine x, okay? So what do I get? What integral do I get, which is of the form u du, basically? So Jaden says, how did I get x squared instead? Um, I'm assuming that's for the previous question. Well, as you know, as just try it, okay? So try taking the derivative and then trying to eliminate the x terms after you've taken the derivative, okay? And you can always rewatch these videos. Okay, so we've got Jaden coming in with u to the power of 3 du. Natalie as well. I think Kevin was in there first. Yeah, good stuff. All right, so let's go through this. So going to the next level, really, hopefully we can now make a better understanding of how to assign u or which substitution to make. So once we let u equal to sine x, and we take the derivative of both sides, we get du with respect du by dx is equal to cos of x. If we rearrange to make dx the subject of this equation and substitute all our u terms back into the original integrand, so we know that sine x cubed is going to be the same as u cubed, and dx is going to be the same as du over cos x. We get cancelling, don't we? Okay, and we now have a final integrand of u to the power of 3 du. Very, very good, guys. That was fantastic. Good stuff. I see some of us going all the way there. I think it's Din. Very, very good. I think, was Kevin in there first again? Good stuff. All right, let's move on. Next question. Find the change of variables for this integrand. Think about what we did in the last slide. In order to assign our u, we set it equal to the denominator, didn't we? Okay, so that's your clue there. Who's got it? Who's got it? Who can work this one through? Who's going to be quickest in? Right. Yeah, correct. yes, you wouldn't substitute that sine x straight away. You'd have to integrate it first, okay? Okay, so we've got an answer in from Kieran who says du over 2 plus 2 sine x. Okay, so we're just looking for the change of variables. So we're only looking for an integrand in terms of u effectively. Okay, so we've got d over 2u, we've got 1 over 2u du. Okay, cool. Starting to get some in. Good work, guys. As Stuart said earlier, we're definitely going to need our pen and paper for today, okay? You definitely have to write these down. Let's go. Okay, so let's have a look at this. So as always, right, we have our function u. Okay, we've got u is equal to 2 plus 2 sine x. So we need to take the derivative with respect to x, and we get 2 cos x. Okay, we then need to rearrange to make dx the subject of the equation. And then we need to substitute this together with our u term to get this integrand, okay? So this is what we're left with when we substitute dx for du over 2 cos x, and we substitute 2 plus 2 sine x for u, which we've assigned here. This is what we're left with. And hopefully you should now see that there are cancelling of terms. The cos x's cancel, and that leaves us with a final integrand of 1 over 2u du. So I think it was, yeah, good stuff. I think Natalie was in first there, and then Ella, and then Jaden. Fantastic stuff. Good going, guys. Fantastic. The last one is one to think about, okay? Slightly harder. Okay, so here I'd like you to do the same thing, but I'd like you to use a suitable trigonometric substitution. Okay? Here's a question. What does cos mean? Cos means cosine, buddy. It's a type of trigonometric function. So this one is slightly harder. Well, the point is that in the exam, they could actually make you use a suitable trigonometric substitution, okay? Not to say that it can't be used, you can't use other ways. Okay, so we have Miriam coming in saying that you should be sine x. Okay, good stuff. Gonna help you guys out here, all right? Because we don't have much time to go through the last question. So using the Pythagorean identity sine squared x plus cos squared x is equivalent to 1, you should see there is some relation in the denominator, okay? So letting x be equal to sine of theta, we can use this as our substitution, okay? So differentiating both sides, so this time we have to differentiate x with respect to theta. This would give us cos theta, okay? So rearranging as always to make dx the subject, we get the following. So dx is equal to cos theta d theta. So we can put that in place of dx. And substituting, well, we know that we've set x equal to sine theta, so the numerator would be sine theta. And using the identity, well, if we subtract sine squared x from both sides and we take the square root, we get cos of x, right? So the same thing would work with cos theta. Okay, so taking the square root of 1 minus x squared would be equivalent to cos of theta. All right, so then you should see that there is cancelling between the cos of thetas, and that gives us a final integral of sine theta d theta. All right, so good stuff there for recognizing Miriam. I'm not sure who else got that one there, but fantastic. Good. All right, I think we should go to the last question of the day, and this is going to involve you guys to use your calculator. Let's go. Okay, so using a suitable substitution, find the definite integral of e to the power of tan x over cos squared x dx integrated between 0 and pi over 4. So you're going to need your calculator for this one, guys. That's a pi, by the way. That's pi. And yeah, here's another thing. I'd like you to give me an exact value if possible. An exact value, please. So the first hurdle is always, what substitution am I going to use? So which substitution am I going to use here? That's the first hurdle always. Remember what we said earlier about always attempting to choose a function which, when you take the derivative of that function, gives you something that's already there almost. Okay? To start with, what functions have you assigned, guys? What has been your u substitution? So we've got Kevin saying u is equal to tan x. Right, good stuff. Very good. Okay, bear in mind I've been a little bit harsh here because in the formula booklet you will be given a certain derivative, okay? Okay. Thank you guys for trying that out. As we come to the half-hour mark, I'm gonna go through. Feel free to continue to work through it with me as I go along, and if you get the answer, feel free to just pop it on the chat and we'll confirm. All right. So in this question, we need to integrate this integrand, and one of the things we said was when we're choosing a u substitution, always try and find something that when you differentiate it, it gives you something that's in the function. Okay, now as I said, I was a little bit harsh here because I didn't give you the formula or the actual derivative, but the derivative of tan x is sec squared x. Okay, so choosing u to be my u equal to tan x to be my substitution, as we just mentioned, if we take the derivative, we get sec squared x. Now, this is included in your formula booklet, so you won't need to worry about that. Now, why have I chosen tan x? Well, there is a relationship between sec squared x and cos squared x, isn't there? What's that relationship? Well, sec squared x is just a reciprocal of cos squared x, okay? So we'll see how that pans out going forward, okay? So what we get next is just writing out sec squared x is equal to 1 over cos squared x, and simply just making dx a subject of our equation. We get dx is equal to cos squared x times by du. All right, so as always, just subbing our terms back into the original integrand, we get the following. We get e to the u times by cos squared x du divided by cos squared x, okay? And now you can see a cancelling of terms, okay? So that's going to give us a final integrand of e to the power of u du, okay? Now, in order to find the definite integral, we need to evaluate at the bounds, okay? Now, in order to do this, you would need to change the bounds, okay? Because we've changed the variables for the integrand, we need to also change the bounds from x bounds to u bounds, okay? So what we need to do is, from equation 1, we need to find out the value of our upper limit, which would be tan of pi over 4, okay, using equation 1, and that's equal to 1. I'll always advise you to keep your calculator in radians, okay, of course, at A levels when you're dealing with trigonometric functions in general, okay? And to find the lower bound, u2, we simply just plug in tan of 0, okay, into our calculators, and that gives us 0, okay? So integrating between the two bounds, we get a final answer of e to the power of 1 minus e to the power of 0, which gives us e minus 1 is our final answer. Okay, that's going to be it for today. Thank you very much, guys, for joining. I'm just going to put back on. All right, guys. Thank you very much, guys, for joining us today. It was a very, we tried to put in as much as possible in the space of half an hour. Please do watch back the videos. I'm going to drop some links below of some really useful videos that Stuart's made in the past. He's got plenty of different types of integration questions. Generally we like to go through these things step by step and, go through a sequence of the same type of questions, for a whole lesson. But of course, we're trying to get as much information as possible. But hopefully you guys picked up something from this. If you guys have any questions, feel free to drop them in the comments. If you enjoyed the lesson, just drop us a like. That'd be fantastic. Thank you very much to Stuart for helping us out. You guys, you guys have been great for contributing as always. Tomorrow we have GCSE mathematics. We're going to be continuing quadratic sequences where we didn't get to start that the last time. So we're actually going to start it tomorrow and do some more involved questions. All right. Request your topics and we will get them done in these live streams. Okay. Thank you guys for coming through, and I will see you guys all tomorrow. Take care, guys. Bye bye.